All right, the next problem, and the last problem for this lesson is looking at gravity of the moon, where d is distance and t is the amount of time. It's a measure of gravity, and it's a little bit different than our gravity. So we want to find the average speed of an object drop from 1 to 2 seconds. Now, I'm going to pull up a graph real quick, and by this time, I'm just going to pause the video and pull it up, typing in this equation, but I'll change the t to an x. And so here's our picture. So if we want to find the speed, we're going to say these are the x values. And so to find the speed at which it falls, or the distance, we type in 1 second. So at 1 second, I would have 2.7 times 1 squared, which we know equal 1 squared is 1. So this is simply 1 times 2.7, which is 2.7. That would be 2.7 feet is how far it fall after 1 second, or the speed at which it's, or that's the distance, I'm sorry. That's the distance it falls after 1 second. Well, let's check the distance after 2 seconds. It would simply be 2.7 times 2 squared. 2 squared is 4 times 2.7. This would be 10.8, I believe. Let me check that real quick. Yes, it's 2.8. So 2.7 times 4 is 10.8 feet. So now the average speed would be feet divided by time. So we'd again be looking for a secant, is we would say that f of 2, which is 10.8, minus f, this value, the first value, divided by the second x minus the first x. So when we subtract this, we get 8.1 over 1. So the average speed is 8.1 feet per second. Now you can try the second. Oh, I'm sorry. Now I got a second one for you. So this time we're going to look at the same thing, but now we're going to look between 2 and 3 seconds. So I'm going to pull that same graph over, and now we're going to look at some values. I'm just going to pull over the F2 value from previously, and now let's just find the third distance. And so if I plugged in 3, I would have 2.7 times 3 squared. So that's 9 times 2.7. And I believe 9 times 2 is 18. 9 times 7 is 6.3. So I think that would be 24.3. We could check that out in the calculator just to double check. Let me pull up my calculator here. 2.7 times 9. Yeah, that's 24.3. And so now we have our two distances. Now let's find the secant line here. So the secant line would be the second time, or the second distance, which is 24.3, minus the first distance, 10.8, over the second time, which is 3 seconds, minus the first time, which is 2 seconds. So what do we get? Here when we subtract, we get 13.5 over 1. So this is now falling 13.5 feet per second, which makes sense. It starts to speed up the longer it falls. Now you have one to try.